So we talked before how natural language, such as English, can be very ambiguous. Such a simple word as any can mean totally different, almost opposite things. So instead, here we will try to use a language of logic, which is designed to be a little bit less ambiguous. And in this video, I will talk about the building blocks of the language of logic. So the very first building block is one unit of meaning, a proposition. A proposition is a sentence that can be either true or false. For example, "It is raining in St. John's right now" is a proposition. It can be true, it may be raining. It can be false, it may be not raining. But at least at any given time, you could look outside and assign a value true or a value false to that sentence. Similarly, 2 + 2 = 7 is a proposition. It can be true, it can be false, depending on your meaning of 2 and 7. I'd say it doesn't look very true if the numbers are what we're used to, but still it's a proposition. It has a truth value, true or false. What are things that are not proposition? If I say hi, well, cannot quite say if it was a true hi or a false hi. That would be strange. So hi is not really a proposition. Or if I ask you what is x, again, you cannot really say what is x. This is a question. It really doesn't have a true or false value. And often, just like in arithmetic, you use letters to denote numbers that you don't yet know. We will use propositional variables, letters A, B, C, or P, Q, R, to denote propositions. So rather than writing "It's raining in St. John's right now" many times in a formula, I'm just going to use the letter A to denote that sentence, in a sense that if it's raining in St. John's right now, the variable A would take the value true, and if it's not raining in St. John's right now, it would take the value false. So now that we have the very basic building block, the proposition, which sort of plays the role of numbers in your arithmetical formulas, let us look at what plays the role of the plus and times and minus in your arithmetic formulas. And here we will look at several connectives, logic connectives. The main ones are probably the negation connective and not. And if I say not A for some proposition A, I would mean that the opposite of A should be true. So for example, if it's not raining outside right now, I say it's not that it's raining outside right now. Well, that would be true if there is no rain, and it would be false if there is rain. Another useful proposition, another useful connective is conjunction or and. I will usually say and because conjunction is too long a word to pronounce. And and of A and B is true whenever both A and B are true. When I say "It's raining and snowing," that sentence would be true if it's both raining and snowing at the same time. Similarly, there is a or connective, and A or B would be true if at least one of them is true, or both of them. We will see example of that later on. But so far, I'm just showing you the symbols and kind of hand-waving the meaning of those symbols. So there is not, and or. And the last one that I will show you today is the one that you would use if you're translating a sentence "if A then B." We called it an implication. And as you've seen in the card example, "if A then B" would be true whenever if A is true, then B is also true. That is the only time if A then B can be false is when A is true and B is false, whenever the elected politician didn't deliver on her promises. So let's try some simple examples. Suppose I have an English sentence, "It is sunny," and I call it proposition A, and another sentence that says it's cold, and I call it proposition B. Now, if I write not A, this will correspond to saying it's not sunny. Is it true that it's not sunny? Well, if it's sunny, then it's not true. If it's not sunny, it is. Similarly, I write A and B for the sentence it is sunny and cold. I write the sentence A or B for the sentence it's either sunny or cold or both. It could be a nice winter day when sun is shining and the temperature is below 0. Finally, I could say if it's sunny, then it's cold, which is something that can happen in the winter. The days that are nice and bright tend to be colder than the days when we get a bit of fog and rain. So now that we have the basic building blocks, propositions, propositional variables, and connective, we could build formulas out of them, just like you would build arithmetic formulas out of numbers, variables, and operations. For example, if you have a number 3 and a variable x and z, you could build the formula x plus 3 times z. Here, plus and times are your connective, and you have a number 3 and 2 variables, x and z. So in logic, instead of 3, we could have just 2 things, true and false. Here, by true, I mean something that always has the value true, and false, something that always has the value false. And then we have proposition, which sometimes can have value true and sometimes can have value false. So the simplest possible formula is a proposition. If I say it is sunny, well, it's a logic formula. It's something that may be true, may be false. It's a statement in logic. And then I could take those simple statements and combine them together over and over again to get more and more and more complicated sentences. I could say it's sunny and it's cold. If it's sunny and it's cold, then it's snowing, and so on and so forth, building bigger and bigger and bigger ones. So let's try some examples with those A proposition for being sunny, B proposition for it's cold, and C for snowing. Suppose I show you a formula which says B and C implies not A. How would you translate it back into English from the language of logic? So here you can refer to the table of the connectives for all the symbols. So you may think about it as writing the names of the connectives and putting some marker for the proposition, some picture like here. If cold and snowing, then not sunny. So now it starts making a little bit more sense, and you could just write it in English word. If it is cold and snowing, then it's not sunny. Okay, suppose you have something that's written as B implies C or A. Again, B was it's cold, C was it's snowing, and A was it's sunny. And the whole sentence will be, if it's cold, then either it's snowing or sunny. Let's try another example. So not A will be it's not sunny. A will be it's sunny. And C is snowing. So you end up with a sentence, if it's not sunny and sunny, then it's snowing. Okay, that's kind of a weird sentence, doesn't quite make sense, but still, the way it's structured is a perfectly valid formula in the language of logic.